because you should know one quote by one of the great men of this world. You must be knowing Warren Buffett. Yes, Warren Buffett, the richest man in the world. Listen to what he says. He says, very soon, farmers will drive Ferrari and IT experts will drive their tractors. So you are in the right auditorium, where I also want to congratulate ATPBR for organizing realigning Indian agriculture. This is exactly what Albert Einstein also wanted to say. He wanted to say, we have to go on a different path than if you want to solve the complex problems. We have to go on a different path to solve the complex problems, because the paths which created those problems will not be good to go on to solve the problems. So this objective of realigning Indian agriculture and the statement by Albert Einstein, I believe that it's the same objective. This is the situation of an Indian farmer 75 years after independence. This is not the best situation, and this will not attract all of you, I know. But I want to tell you a story today where a farmer can be like this. Farmer can be happy and he can be prosperous and he can contribute big time to this country. These are the examples. This is the example. This is the example. And this is a technique about which I will be talking today, is SRT, Saguna Rice Technique. This is a no-till. Saguna Rice Technique is a no-till conservation agriculture practice, regenerative method of farming, where erosion is stopped completely, where carbon is fixed, where the farmer becomes happy and confident. These are some of the most important aspects of Saguna Rice Technique. For example, this farmer here from Pune district, he used to grow only one crop. Now he grows 3 crops. He has only 1 acre of land, but because he takes 3 crops, this land has suddenly become 3 acres. He is able to take 3 tons of fragrant rice in Raini. Then after rice, he is taking lettuce, and after lettuce, he is taking broccoli. Putting all together, he is able to make more than 3 lakh rupees a year per acre, and that's very good. This is what we want, and if we can give such a technique to the farmer can become happy and confident. This is a very common scenario in northern India, in Punjab, Delhi, burning parali, burning rice stubble, and creating problem for the environment. Actually, it is creating big problem for that soil also, and soil is very important. Soil is very important for the farmer, for environment, and for easy and affordable food for the public. But when they burn the parali, it's not that they want to create a trouble for everybody else, but they don't have a way, they don't have a choice, they don't have a different way, which Albert Einstein wanted, and which we are thinking here, realigning different method, different approach for sustainable future. SRT is some such technique where growing wheat after rice without ploughing, without burning the parali, it is possible. In Maharashtra, we have got 50 plus farmers doing this, and their crop is extraordinarily good. Their crop of rice, their crop of wheat, both the crops are very good. Rice, as I told you, 3 ton, 4 ton rice per acre is becoming very common now with SRT technique. And this wheat, we haven't got the figure yet, but it is certainly more than 2.5 tons per acre. And you can see there are many different crops can be cultivated with this technique. This is soybean. This is a collage of different stages. Rice is harvested, soybean is planted, and you can see this is, you can say, a situation a week before the last right corner picture. But these are the enemies of the land, of the farming, of the environment. I'm not talking about tractors, I'm talking plowing. That it's the plowing. Plowing is the biggest enemy of farming. Plowing is biggest enemy of the farmer and farming profession. I'm sure when we have been talking so much about science since yesterday, we all know it's the microorganisms which are the most useful profession in actually the farming. During the microorganisms, one plowing is equivalent to one major fire, one major and one earthquake putting together microbes. These are the results which we saw in earlier pictures, and I'm going to you further. What happens to the soil, what happens to the farmer, and what happens to the farmer. If we can avoid plowing, many good things happen to the soil, many good things happen to the farmer. This we know, I mean, science knows tillage, plowing is bad for soil, at least for last 60-70 years. But this is the development is still happening. In big machine manufacturers, they are trying to figure out, they are coming up with bigger and bigger tractors. I mean, bigger and bigger and more powerful plows and tractors, of course. But tillage certainly is the enemy for all of us. And in all over the country, I'm sure, all different state governments give subsidy for this. But what happens in rice cultivation, especially plowing, puddling, transplanting, these are the big hurdles for the farmer. When we do this, such kind of puddling, this is what is happening. And this is not just muddy water. This is blood of our motherly land. How much of that blood is going? I took half a liter of water, that muddy water, applied alum, put it in my home for 2 days, and then decanted the clean water. You can see in these 2 glasses where a rose petal is kept on top of it so that you could see the water. So these 2 glasses are filled with clear water from half a liter. That's 200 plus 2, 400 liter, and half a glass is the blood of my land. That is 20% beautiful soil, beautiful silt is lost each time we do rice planting by puddling method. And we have to stop it. Soil erosion is the biggest aspect. Now, all the students, I know you must be wondering whether I'm asking you to go and work in the farm. No. But there are lots of aspects where science has to be validated. All the things which I'm talking are empirical observations. It needs to be validated by science. It needs to be convinced to the scientific community. And this needs to be carried to the farmers where it is needed. And further research is required. For example, developing the varieties, developing the right tools. All these are there are many aspects where your proficiency, your expertise will be utilized. Normally, at least in Maharashtra, this is still the scene. I don't know in South India, Ravi, is it the same situation? Yeah, it's all over the country. In Punjab, I know they still do this. But this is terrible. I don't know if farmers are going to be getting that much water and that much labor as the years pass by. I don't think it is possible. Even labor is becoming difficult now for the farmers. So these are all difficulties that are coming to the farmers where we have a better option of no-till, and that is SRT. This is another problem of our environment, global warming, drying of the lands, and there are so many different problems that farmer is facing. So what we need to go from degenerative method of farming to regenerative method of farming. We have to stop plowing our land, and we have to go by this method where I showed you that without plowing the land, you can cultivate many different crops. On my farm, we have not plowed our land for last 10 years. For almost 20 acres of land, we have not plowed it, and we are getting each year where our soil is becoming better and better, and we are getting better crop. This is the science. This is the simple science of our technique. This is carbon sequestration, where the carbon should be in the soil. It is escaped into environment, into atmosphere. Today's condition of our atmosphere is we have got 425 parts per million carbon dioxide. It should be below 350. We are adding three parts per million every year. So how many years do we have? 450 is the higher limit. 450 minus 425. 25 divided by 3, we have got less than 10 years. It's very difficult situation. But there is a simple method which is designed by the nature. And this method, after millions of years of experimentation by nature, this is a method how to balance the carbon. So whenever there is photosynthesis, there are 4 things that are happening. Cooling effect, production of simple food, it's throwing out something, that's oxygen, and it's eating away carbon dioxide. But the process doesn't stop there. After photosynthesis, there is resynthesis, conversion of simple sugar into complex products like protein, lipids, oils, etc. The third one is exudation. 40% of the simple sugar are exuded through roots, so that the microflora in the rhizosphere are supported. And the fourth stage is humification. The same microbes convert that organic matter which is fallen around. They convert that organic matter into humus. And humus is a stable form of carbon in the soil. 50 to 100 years, no problem. It remains there, and it is utilized by plant growth and microbes as and when it is needed. So these are the 4 steps which need to be carried forward while we produce our food, while we address our food shortage problems and global warming problems. So carbon, this is the liquid carbon pathway basically, and this is the science. This is all very simple to understand and simple to practice, but lot of complex research need to be done, and that is realigning Indian agriculture. We have to go different way. This what we have been doing is plowing, this, that, developing machines and varieties for the conventional method of farming. We have to stop and go in a different way. This is another picture of regenerative and degenerative method of farming. In the regenerative method of farming, we fix carbon dioxide and we bring in moisture into the soil. We make our soils healthy. They become moist, and there is better water holding capacity, better drainage of water, and better exchange of water and nutrients. Whereas in degenerative method of farming, which is done by big machines, the CO2 escapes and water also escapes. So we have to go from degenerative to regenerative method of farming, and the soil becomes like this. This is the soil in our farm. Our soil was not as good as this. 10 years ago, the clod was so hard, if I threw at a dog, the dog would die. But today, the same clod I can take in on any of my hand, and I can crush it into beautiful soft soil like this. Our organic carbon is more than 1.5%, or close to 1.5%, 1 to 1.5%. It used to be 0.3%. One of the most important thing that we have achieved. The whole world was looking for this. Presence of earthworms in paddy field. Presence of earthworms. They wanted to bring in earthworms. Japan and America tried to do this, achieve this after spending a lot of money. But by accepting SRT, Saguna Rice Technique, almost 5,000 farmers of Maharashtra in 30 districts, including 30 different crops: rice, maize, cotton, vegetables, groundnut, onion. Everybody is saying that we've got earthworms, and you can see from this picture all different types of soils have got earthworms. This is a great achievement which we have got. Our biodiversity has increased, and when I say biodiversity, is the visible biodiversity. The invisible biodiversity in the soil, different types of microbes, and the number of different types of microbes, that also is increased. I know, but we don't know. That needs to be validated by you experts. But these are the things which we have appointed a team of 3 MSc students of zoology, and this is what they found out in last 3 months. Of course, this is the work of past maybe 20, 25, 30 years, but especially in last 10 years since we started SRT, our increased in visible biodiversity is drastic and very remarkable. For example, butterflies and moth 52, reptiles 17, spiders 27 different types of spiders we are able to point and count. So this is all wonderful biodiversity that has happened. This was a workshop, one-day workshop just 10 days ago, and you can see Dr. A.R. Sharma. Some of you may be knowing Dr. A.R. Sharma from Weed Research Institute. Now he is in Jhansi. And the person who is talking to me is Dr. M.L. Jat from CIMET, head of India for CIMET. They were all there. And one farmer, the farmer is on my left-hand side with a white cap. 1 acre tribal farmer, 1 acre tribal farmer whose income was 15,000 rupees in a year, and he had to live by working at somebody else's place. Now he grows almost 35 different types of crops, and so resilient, so beautiful. The cost of production is not even 30% because his family works in the field. And his income, his sales is more than 3 lakh rupees. From 15,000 rupees to 3 lakh rupees sales, after keeping all the required things for his family for the whole year. So he's become very happy. He talks science now. Dr. M.L. Jat and everybody was surprised to listen to him. He spoke in Hindi, and it is happening. So even the smallest of the small farmer is becoming happy, and he's becoming like a scientist. He talks like scientist. This is the same guy. He's showing the quality of soil, how the soil is changed. This is what he's showing, and it's fragrant. Every 365 days, you can get the same fragrance as if it is the first rain. And of course, Dr. M.L. Jat, he was there. And these corn on the cobs are much better than the ones that are kept outside in the exhibition. And this is only 2-year SRT farmer from Aurangabad. The farmer is not there. That's Dr. M.L. Jat and Dr. A.R. Sharma. But I brought these cobs from SRT farmers so that we could give this bouquet to these people. This is the farmer. Can we show the video? This is the farmer from whom we brought this. Let's see his opinion.
I'm going to tell you the story of no-till farming. No-till is not spending even 1 rupee on tillage. If we open up a little soil here, you will see lots of earthworms. The vermicompost has become available here naturally and at no cost. I have planted maize as second crop after tomato without any tillage. Even to do one operation of rotavator, it cost me 1600 to 1800 rupees. All one needs is spraying of one weedicide that costs only rupees 400. All the crop residue of previous crop are seen throughout the field. The plant parts below the ground should be left for the motherly land. If we adopt this SRT technique, no one will think of extreme thoughts such as suicide.
In 3 short experiments, we are going to show you how soil aggregation works in zero-till method of cultivation and what are the effects of water percolation in the soil or whether it flows away as a surface flow. In the first experiment, I am going to show you two clods from two different soils. One clod on the left hand side is from SRT zero-till method of cultivation where the soil was not plowed for 6 years, and on the right side the clod is from the cultivated soil, conventionally cultivated soil, where the soil has been plowed and puddled for 2 times a year. And see what happens. We have taken two clods and put in the water with the sieve, and you can see on the left hand side jar the soil is not falling apart, whereas the soil is falling apart on the right hand side, which is a tilled soil. So the capacity of the soil to hold on when the first rain come, and whether that soil should flow away in the flood or it should hold on. In the second experiment, I'm going to show you what happens about the surface flow when the artificial rain falls on that particular soil. Now this is the soil from tilled field, which is plowed and all that conventionally. And in the second case, we are going to take soil from the zero-till SRT method of field. Now here what you see is we have taken two plastic boxes, and in these two plastic boxes the bottom is removed where the sieve is fitted into the bottom of that particular box, and we have put on the left hand side, this is the zero till soil, and on the right hand side it is the conventionally tilled soil. The artificial measured quantity of water is fallen in the form of rain on both the boxes, and on the left hand side you can see where the water is going. The water is getting absorbed into the soil, and excess water goes at the bottom of the box, collected in the second box, whereas on the right hand side box all the water is flowing in the form of surface flow, and it is coming in the front jar. It is getting collected. In the third experiment, I'm going to show you what happens when the water in the form of rain falls on the soil, how it percolates, and whether it percolates, what quantity it percolates. Now we have taken a plastic pipe, and it is fitted into the conventional soil, conventional field, and we are pouring 2 liters of water in this particular plastic container, and we are measuring the time, how long it takes to percolate 2 liters of soil in situ in that field. How long does it take to percolate completely? And you can see we are checking the time, and after 1 hour so much of water is already left, whereas this is a field which is zero till field, SRT field, where no tilling was done for 6 years. Now here we are fitting this pipe in the same manner, and we are also pouring 2 liters of water in the same fashion in this particular field. Now you can see this pipe is fitted, and we will pour 2 liters of water and measure the time. And let's wait and see what happens to that water and how long it takes. And within minutes, as you can see, we are putting the timer, and now you can see within 25 minutes, this is what happens to the water. All the water is gone, it's all percolated. So on the left hand side, it is a conventional method where the water remains, so much water remains after 1 hour. And on the right hand side, it is a SRT zero till method where within 25 minutes,
all the water gets absorbed into the soil.
Almost 60–70% drudgery of the farmer is gone. So farmers are very happy. They've got a lot of time now, and they are very happy because they don't have to depend on three things. They don't have to depend on tractor or plow, bullocks. They don't have to depend. They don't have to depend on optimum water rainfall. No, the technique is climate smart. So excess rain, low rain, no rain for 1 month, 2 months, no problem. The crop still performs very well. We have a lot of data. So decent work and economic growth, it's certainly addressing this technique. Climate action, we are able to fix. This is our empirical observation and from reading from papers. We believe SRT is, if the right protocol is followed, and if 2 crops are taken, even if it's not taken 3 crops, even if you take 2 crops, the SRT farmer is able to increase his organic carbon by 0.4 to 0.5%, which is equivalent to almost 9 tons of carbon dioxide per year per acre. Fixing of 9 tons of carbon dioxide per year per acre. So climate action we are addressing, and life on land, biodiversity. I showed you the biodiversity. So these are the goals that are addressed. Next, I can do it. So this is what we are doing. This technique is now accepted by FAO for their TECA for smallholder farmer, and they are going to teach this technique all over the world. This technique is accepted. We also have in our country ISRN, Indian Social Responsibility Network. So they also have accepted it in their volume 2, 4 pages of information about SRT. They take it forward. We have our own channel. We make a lot of effort. We have a team which spreads knowledge and technique. And you can see this is used and adapted by different crops. Photos showing different crops, and the farmers from 30 districts, almost 5,000 farmers that we know of, farmers even in Orissa, Karnataka, Gujarat, and some other states, but they are very few. We have not been able to reach them very effectively, but they are already doing it. The wheat crop I showed you, that Karnataka, rice and wheat, he has made wonderful, and he's become very happy. So these are the things that are happening. Many different crops, many different people, many agroclimatic zones, everything, everywhere the technique is working. It's up to you. It's very painful that it's not accepted by our university system. Not they are showing any interest, but farmers and government of Maharashtra have already taken it up. There is a project called Project on Climate Resilient Agriculture. That's POCRA. They have also accepted it. It's World Bank project. But you're welcome. You're welcome to ask me questions, and you're all welcome to come to my farm, Saguna Bagh. We are also a agro-tourism center, first agro-tourism center in the country, and the word Krishi Paryatan is designed by me. So I'm pioneer of that whole concept.
Thank you, Mr. Shekhar, for a wonderful talk and wonderful technique which you have innovated. So we can take up a few questions from the audience. And before that, we have a question with the co-chair.
Wonderful presentation, my dear farmer friend Shekhar. As a farmer, besides being a co-chair, as a farmer, how do you manage weeds? The very purpose of plowing is to control weed.
Yes.
And again, suppose I grow rice after rice. Perhaps I may grow ADT 43 and the next crop BPD 5204. Then the previous rice, the paddy seed that had fallen, that would become a weed for the next crop, and it would be carrying the spores of various fungus. So how do you manage all that?
Okay, yeah. So my farmer friend, so he's thinking, he's already gone to his field and trying to adopt SRT mentally. So he has already the right questions. How do we manage weeds? We, with our technique, we do not consider weeds as our enemies. We consider them as our resource. Because weeds are different types. They all sequester carbon in different way, and they support different microflora around their rhizosphere. So when our technology is to use weedicides and not plowing. When we want to turn off plowing, we use weedicides in the right combination and in precise weedicide application of weedicides. So when we do this, we leave the whole weed as well as the roots of the previous crop that farmer was explaining. He keeps the roots of the previous crop in the soil. So when we do that, the upper portion of the plant is cellulose and lower portion of the plant is lignin. Lignin is a better molecule, it's a more stable molecule of carbon. So it improves quickly the organic carbon of the soil and health of the soil. So we use pesticides. We have a little booklet which we are going to, it's in Marathi, but in next month, within month, we are going to make it in Hindi and English. But it's all there. How do we manage our pests and diseases? There is a scientific principle. If there is more organic carbon in the soil, and organic carbon formula is CHO, it's the same formula of sugar, CHO. If there is more sugar in the soil, plants absorb more sugar in their body because they want the food to be tasted. Human being should be sweeter. Is because that gives resistance to insects and pests, pests and diseases. We grow in our farm fragrant rice, and we had to use poisonous insecticide at least 3 to 4 times in the span of 4 months. But for last 5 years, we have forgotten that we need to use insecticide. Though we don't organic, but we make sure that our organic of the soil becomes more, it becomes healthy, and if the soil is healthier, the crop is resilient. And also one more thing is all our crops, the cotton, whether it is soybean or vegetables, they're all aligned in crisscross. So there is better ventilation in the field. So there is no microclimate development, which is the major requirement for build-up of insect and disease population. So this is one more reason. This is one more way that we take care of the disease and pest.
Well, so any question from the audience? Otherwise, so Mr. Shekhar, in interest of the audience, if we talk about the statistics, say for the input cost with the no-till and the input cost which is involved for the normal transplanting, say for example rice going with the puddling and all. So it would be good if you can share just what is an input and then what is an outcome, especially in terms of productivity.
Okay, yeah, cost of production and the yield. I will say conventionally, these are the figures from Maharashtra, where the labor cost is 300 rupees per labor per day. The cost of Maharashtra for conventional method, tillage method, is about between 15 to 20,000 rupees per acre. On an average is 1,000 kilo of paddy. Whereas in case of SRT, The cost of production for SRT no-till farming is about 5,000 rupees, including fertilizer, and the yield is minimum 2,000 rupees, 2,000 kilo. Minimum is 2,000 kilo per acre. But there are farmers, there are many farmers, there are dozens of farmers who have been getting 4,000, 4,500 kilo per acre. They have stood, they have got highest record in their district, state, and all that. There are many farmers like that.
So
And how does it hold with reference to other crops which are being adopted by SRT other than the rice?
other than rice.
In the other crops?
Yeah.
Okay. Cotton is not my crop, so my figures are not very authentic, I would say, but what we have heard from the farmers. A traditional farmer gives almost 9 to 10 bags of fertilizer, whereas SRT farmer is bags of fertilizer. Traditional farmer has sprayed cotton for 13 to 14 times, whereas SRT farmer has sprayed only 4 times. Traditional farmers yield, this I'm telling you in Aurangabad, traditional farmers yield was between 5 to 6 quintals, and SRT farmers yield has been 12 to 13 quintals per acre. I guess, yes. Yeah, BT. 90%.
And from the farmer's perspective, I would like to add something more to it. So I have been growing rice in small area using drip system. So as you rightly said that rice is not an aquatic crop. Rice tolerates little bit of water, but nevertheless it cannot be sustained with by stagnating more and more of water. So 1 hectare of land means 10,000 square meters. So if you stagnate 10 centimeters, normally farmers, we stagnate 10 centimeters water, that means 1,000 tons of mass we are putting on that 1 hectare. That puts enormous pressure on the soil. Definitely it creates a hot pan, and that is really, the air circulation doesn't go. These are some of the challenges. And besides, by stagnating water, rice, it is by stagnating water and growing rice in an inundated condition, it emits a lot of this CH4, methane gas. Royal Norwegian government, they conducted an experiment in my farm, Tamil Nadu Agriculture University and the Royal Norwegian government, to measure how much of CH4 does my rice crop emit. Since then, I do this alternative wetting and drying method. After seeing your presentation, I'm going to try it in my farm. So it is too good to be true. Thank you, Mr. Shekhar.
Yeah, can I comment on that?
Mr. Chairman, sir.
One of the thing was hard pan making in the soil. Hard pan making in the soil is not just because of the pressure. It's one of the, I learned it today. But another very important thing, when we plow the land, only top 9 inches of soil is loosened up. But where the plow is rubbing at the 9 inches below, once, twice, thrice in a year, it's actually compacting, it's creating a hard pan, which stops soil water infiltration, stops the movement of all different earthworms, insects, and so on from up and down. So it creates many environmental problems by plowing the land and creating hard pan. The second aspect is methane generation, gas generation in the soil, in the paddy field, because of anaerobic. Scientists, philosophers threat the world. That's because and Bush also, when he came to India, just before that he said, you Indians and you Asians eat rice, that's why global warming. On that. It is true that in method, in this convention and plowing is lot of gas emission is that is taking place. SRT, 0. If there was any methane generation, the earthworms would not come there. This is our empirical observation, but this is for you students to find out, figure out. And I'm ready, this is what, if there are any university community professors and around here, please take up this note, take this as one of the challenge that we have these facts and figures scientific, and I'm ready to work. We have an NGO, and I'm ready to work with to precisely find out is the truth, because this is one of the major thing that India can give to the rest of the world. India has the biggest potential to sequester carbon, to stop emission, and to stop fossil fuel burning and generate. We can get, the farmers can get a lot of money on carbon credit. It's going to be a big thing in India now.
Chairman, sir, can I make a point?
And definitely we'll
Hello.
connect one-on-one for having more, elaborated things on
Hello.
it. So thank you once again. And
Can I-
now we are moving to the next
Can I-
speaker.